Welcome to Evidential. Today we are opening the file on a mystery that defied the laws of naval engineering. In the freezing waters of the North Atlantic, 1,500 World War II vessels didn't just sink, they shattered. They weren't hit by torpedoes and they weren't victims of sabotage. They were victims of a terrifying physical transformation. Tonight, we perform the forensic reconstruction. The steel that turned to glass, the Liberty ship Autopsy. In the midst of World War II, an ominous ghost started targeting American supply vessels. They weren't struck by torpedoes, nor did they hit mines. They weren't even far from shore. The failure. The Liberty ships, crafted with the aim of winning the war, began breaking in two, cracking right along the hull, while docked peacefully. The conspiracy. 1,500 vessels experienced catastrophic fractures. Initially, investigators suspected sabotage. But what they uncovered was far more alarming: a hidden defect within the steel itself. Tonight, we delve into the materials science behind the Liberty ships, when steel became glass. The need for speed. In 1941, the US required cargo ships at an unprecedented speed. Traditional shipbuilding methods with rivets proved too slow. Thus, the Navy opted for all-welded construction to rush production. Rivets versus welds. In a riveted hull, a crack that emerges in one steel plate would halt at the edge, restrained by the next rivet. However, a weld forms a seamless piece of steel. If a crack begins, it can easily spread. The stress points. Forensic studies of the damaged hulls identified the origins: the sharp 90-degree corners of cargo hatches. We refer to these as stress concentrators. Micro cracks were forming in these tight corners. The fatal variable, cold. But why were these ships snapping abruptly? The last factor was the environment. The Liberty ships were constructed in warm ports like California, but ventured into the icy North Atlantic. Ductile-to-Brittle Transition. Here's the science behind the catastrophe. Many believe steel is always ductile. It bends and absorbs energy. It deforms under pressure. Yet steel has its limits, known as the ductile-to-brittle transition temperature, like a chocolate bar. As the temperature of the low-grade, high-sulfur steel used for Liberty ships plummeted to critical thresholds, around degree 8, its molecular structure changed. It ceased to bend. Instead, it resembled a massive, brittle pane of glass. A crack that began as a tiny imperfection in a hatch corner spread through the entire brittle hull at speeds exceeding 2,000 meters per second. The ships didn't just crack, they shattered. The forensic fix. Naval engineers needed to implement a retrofit based on fracture mechanics. They rounded hatch corners to alleviate stress and added crack arrestor slots to the hulls, effectively bringing back effective principles from traditional riveted designs. Conclusion. The Liberty ships didn't require a miracle to prevail in World War II. They needed fundamental material physics. While the enemy fired bullets, our engineers contended with the very principles of metallurgy. Subscribe to Evidential. We transform folklore into forensic insights. What scientific truth shall we explore next?